Okay. Now, we have been talking about construction for last 2.5 to 3 lectures. Today, inshallah, we'll finish it. And there were only few slides which were left on Thursday. So, inshallah, with this, we will be, inshallah, concluding the material for the 316 as well. So, alhamdulillah, we come a long way. We started the semester with basic understandings of, object orientation, and then we looked at architectures, and we looked at some examples of architectures as well, like Skype and Hadoop and Napster, and then we looked at packages and the different matrices for packages and solid principles and design patterns and refactoring, and we have been talking about construction. So today, inshallah, we'll be finishing the core material, which is supposed to be covered for 316. So just to refresh the memories, we've been talking about construction, and we have been talking about how we should be writing construction specs, and we had a look and discussed the difference between deterministic versus underdetermined specs, and we also had a good discussion on declarative versus operational specifications. And the other day we talked about how we can compare strengths of specifications with reference to preconditions and postconditions. So this is something, the 3 dimensions we covered, and to help us better understand that how basically we can do or how we should write specs. Now we started talking about the usefulness of how we should write a useful specs, and what are the good specs. So probably, though we covered some of these slides, but I think probably just to be again, to be more cohesive and self-contained about this today's lecture, maybe I'll start from this point again, which is all about we know the 3 dimensions of specifications. We know that how we can what's the deterministic versus underdetermined, or declarative versus operational, or the strengths of the spec. So how I should use these concepts to write good specs. At the end of the day, the whole idea of writing specs is that you're trying to make sure that the developer is able to understand how what are the things which are required by this method, and you leave to the best of your ability and best of your design. As a design decision, you leave, depending on the context, you either leave the implementation flexibility to the developer, or you somehow constrain it. So it's all design decisions. Whole idea is, at the end of the day, no matter what you do, is the whole idea of specs is that you want them to be clear, well structured, and easy to read. That's the whole aim of the writing specifications. So that the moment you will be doing it, of course, you will introduce less ambiguity. As a result, you will benefit about maintenance. You will benefit about having probably less bugs, or potentially less bugs, and so on and so forth. So this is the whole idea of why we are interested in writing specs, and why I want to write good specifications. So, of course, we want our specs to be more coherent. We want them, and this is not only true for specifications. This has been a general rule of design anyway, if you notice throughout the semester. So, for example, when we looked at this example the other day, we said that let's suppose we have a sum find method, and it will be taking 2 arrays and a value, and there's no precondition in this case. The post condition is that it will return a sum of all indexes in the array at which the value appears. Now we said that this is a bad spec, and the reason we argued that this is a bad spec is because this method, eventually the one which will be developed, this sum find method, will be doing several things. It will be trying to find 2 arrays and summing their indexes, and we may believe that looking at the eventually the aim of this method, probably it's not single responsibility in a sense, and we are better off splitting them into 2 different methods. Again, again, the rule here is that when you're writing specifications, make sure your methods are doing one kind of responsibility. Don't make, or let's, in other words, we should have them more as a coherent ones. We should not having, mix and matches of long arguments, too many, different computations happening within a single method. This is, one advice. This is one rule of thumb. Similarly, we had a look at this example the other day, and we said that okay, we're counting the long words in a list, and this is for sure a better explanation of the method. So the specs are there. It's telling me that what the method will be doing, so I don't have to read the code, and it tells me, for example, that update the longest word to the longest element of the word and prints the number of the elements in the length, which is when it's greater than the long word length. In this case, it was defined to be 5. Uh, so this is better than this one naturally, but then the general problem in this kind of specification is that if you're using a lot of global variables, this is again not encouraged, and of course it's not coherent either, because this method itself is suffering from the same problem. This method itself is actually kind of doing two things. If it's counting words and then finding the longest word, again, as was the case in the previous example, maybe we should just split them into two different methods. It will be easier to understand, it will be easier to read, it will be easier to define your preconditions, and probably it will be easier to even maintain such an application. So this is another important thing for us to understand, that when we're writing specs, again, the idea is to write specs which will eventually be written by the developers as source code, and we want that source code to really have all the design properties we're aiming for. Moving on, when we looked at this example on Thursday, this example, we're putting a certain, value into a map. So we are saying that as a precondition, value can be null, and map can contain null values. So as a result of the post condition, we insert that key and that value into the mapping, which is all good. But we are, in this case, we were saying that unless none, for example, if doesn't exist, for example, we'll be throwing some null values, or we'll be returning a null value. The problem here again with the null here is that you're leaving this up to the interpretation of the developer now, or the client of this method, because this null can be misleading here. So basically, if you are going to return this null value, this is more like your special return value is missing. So this means if the null is returned, you can't tell whether the key was not bounded, or whether it was in fact a null value itself, right? So again, this is the third rule we learned, that it's not recommended to use such kind of throw such kind of exceptions or return values. In this case, return values. Don't use these return values which could be ambiguous. Again, this is true for even our source code, which means we need to be careful about them when we're writing our specs, that they are clearer, less ambiguous, and it should have a clear understanding, or the return values or the post conditions should have clear unique properties or characteristics, and it should not be mixing many things together in a one return value. Like if you recall, we talked about this -1 example previously as well, that if is it -1 doesn't mean that there is an error, or it means that you in fact return -1. So this is another one we want to be careful when we're writing the specs. Uh, uh, Another thing which is also very important is that the specs should give clients strong enough guarantees in general, right? And it needs to satisfy their basic requirements. So in other words, we must be very careful about when we're specifying our special cases. We don't want to just undermine the usefulness of our method if you're not very careful with the special cases. So for example, this example we looked at the other day, it's actually adding two lists, right? And it's there's no precondition in this case. The post condition was that you're adding elements of list 2 to list 1, and we said it's all good unless you encounter a null element, and at that point you will be throwing a null pointer exception. Again, this is, as was the case that you're returning a null value and it's misleading. Similarly, throwing a null pointer exception when you are actually dealing with null elements can also be a reason for you to have a bad specs, because if the null exception is thrown, the client is left to figure out whether the elements were actually added to list one or not, what happened to it. It's all ambiguous here, right? So this is important again for us to be careful that in other words, the rules we are telling now or thinking as a good design specs is that make sure your method is doing one thing. So write specs in such a way that it's one functionality, so one responsibility. If more than one, split it. Also, don't throw or return ambiguous values. Don't throw such kind of exceptions which could be misleading. And I think we looked at this example and probably we stopped somewhere here that let's say we have such kind of spec where we say a file is open, right? And we're saying there's no precondition to it. The post condition is that we'll be opening a file. Now, again, we said that this is a bad spec. And the reason we said it's a bad spec, if you recall, what were the reasons we said this is a bad spec?
Because it does not have precondition. So I don't know what to do. And it will make it it will make it like complex. Very big.
So in other words, if I'm your client and I'm gonna use an open file in my code and I'm gonna say open file F1, right? Now what I'm guaranteed based on this specification is that this file will be opened, right? This is what's been guaranteed to us. But the problem here is that, because there's no preconditions where they know further details about it, what if you don't have, what if you don't, and it doesn't tell you whether you're opening a file for reading or writing. It does not even tell you whether, file exists or not. What if file F1 does not exist, right? What will happen? Will it, what it will be doing? It will create a file and open it, or because it's promising me that it will always open it. So this is a bad example that you're making things too weak, right? It should be weak enough, but it should not be like so unbounded that anything can be done, and then it becomes such a bad specs that it's not really doing anything. So in other words, and of course, as I said in the previous slide, it's actually very strong post condition. If you notice here, it's a very strong post condition because you're guaranteeing that give me a file and I'll open it. But what if file doesn't exist? What if you don't have permissions for it? Right? It's not handling any of those conditions here. So as a result, if you're gonna use such kind of a spec, because remember, at the end of the day, specs is like a contract, like a firewall. You give inputs, you satisfy these preconditions, you're guaranteed to have its outputs. And if this is the case, what if you don't have permissions? What will happen? It cannot open the file, right? So you have to be, yes, you want some more flexibility in your specs, but you still cannot just go beyond a certain level where you make it so ambiguous, so open-ended. That's the right word. You make it so open-ended, you make it so weak, that's practically useless. Everybody's on board with me on this point, right? All right, guys?
Yes, we are.
Great. So, this leads us to this very important question about specs, which is all about what's precondition, what's the post condition, whether I should make them strong, whether I should make them weak, and so on and so forth. As we had a very useful discussion on Thursday on this point as well. So it's a design issue at the end of the day, right? It's a design issue at the end of the day. Whether you need to use precondition or not, and how strong or weak those preconditions should be. Remember, at the end of the day, for your method to be easy to be used, you like to have minimal preconditions, correct? And you want to give most post conditions, or in other words, you want to put less number of constraints on use of the method, and you want to give more and more promises. This is something you're always trying to do, but it's a design issue at the end of the day, right? And you have to carefully think about, to what level of weakness I want to make my preconditions weak, or how strong I want my post conditions. And it will vary from one case to another. It's a design issue. It will vary from context of the application to context of the application. I'm going to share with you guys now two possibilities, two extremes. Usually, the reason is when you put some preconditions, actually you're demanding a certain properties, certain preciseness, right? For example, if you recall, examples earlier in the lectures when we were using the find method, one of our precondition used to be what? That the array is sorted, right? And as we had that question, I forgot who asked me, but that was a very interesting question, that if I'm going to put such kind of preconditions, this means, I'm putting too much on my client, right? Then, then what's the purpose of this method then, right? If he has to sort it, then what's the purpose of this method? So again, this is a design issue, and one has to carefully think about what level of preconditions I want to put, or what kind of post conditions I want to guarantee. Of course, if you put more poor preconditions, it will be harder for clients to use it. And if you make them too loose, yes, your method will be able to do a lot of things, but then you will have to worry about these post conditions. So, so basically looking at this, you're always looking for, if you put preconditions, of course, you're going to add some inconvenience to your clients, right? Like in the find example, if you're going to say that array should be sorted. So that will definitely put some more constraints on what the client has to do before, uh, they call this method, so that they don't violate the precondition, and hence, they are guaranteed the post conditions. Uh, but putting this, of course, we know this now. I'm pretty sure that we want to minimize it, because the clients or the users of these methods don't like preconditions, right? Because it puts constraints on them. Now, let's look at this example. For example, Java APIs. Now, Java APIs, is something. If you're designing a Java API classes, for example, right? Who will be your clients? Is it be one specific product, or it's going to be a general public which will be using this Java API in so many different contexts and so on and so forth? What do you think? Of course, it's very obvious, right?
It's general.
It's a general, right? There will be so many people who will be using it. We don't know what kind of, how they will be using it, how they will be basically, how they will be calling it. So if you're gonna put preconditions, it's gonna be a difficult thing for you, isn't it? Because if you're going to put preconditions, this means you have to think about all different possibilities where this program will be used, or where this Java API will be used. And then, of course, it will limit it. And of course, then this will mean that, people will have to really understand or satisfy these preconditions. In this specific case, it's recommended that, you basically minimize preconditions, but you handle things like, some things which you cannot guarantee, which something which you cannot process through your post conditions, saying that, if the arguments are inappropriate, I'll just throw an unchecked exception, right? Because by doing this, what you have done as a designer is that you have not put a lot of constraints on this as a precondition, but at the same time, you're not promising everything. We're saying, if the argument is going to be bad, I'll just throw an unchecked exception. Now, by doing this, you have kind of opened up this class for a larger public. Everybody's on board with me on this point?
Yes.
Yes.
Great. Great. So basically, by doing this, of course, what will happen is you make it easy to find bugs or incorrect assumptions about the call, because at the end of the day, it's a general rule that if you have to fail or you have to throw an exception, throw it immediately. You don't want to first go on and process these bad arguments or bad values in your program. You don't want to, for example, this is your math, so you don't want to continue doing your for loop and logics and if else conditions calculations, and then at the end, before return or at the time of return, you throw exceptions. So such kind of classes, or if you develop designing such kind of things, basically, some arguments which you cannot support, or or beyond your defined arguments, you basically immediately throw unchecked exceptions, because it's always good to fail fast. Means let's not do any other calculations. Don't propagate these bad arguments through your program or through your method. Just immediately fail. So this is one case. Now, in some cases, it's not feasible to check a condition, right, without making things very slow. And in that case, you will be interested in putting preconditions. In that case, you will be interested in putting stronger preconditions. And I think this was the question we discussed on Thursday, that, if I'm going to put preconditions, stronger ones, then, it will minimize, or it will put a lot of constraint on clients. What will be a case where I'll be interested in putting stronger preconditions? Of course, this could be one of the case, right? Let's assume you're implementing a find method using binary search, right? And then in that case, you can put a precondition that array is sorted. Why that will happen? Or why are you interested in doing this? Why you will be interested in putting precondition that array is sorted for the find
To make the method less complex
to make the
and
method less
faster.
and faster. What's the link between binary search and array sorted? What's the link there?
For
You would
binary
search on
you
array
need
sort.
Yes.
Array.
So basically, binary search wants a array to be sorted, correct? So for you to do a binary search, you have to have a sorted array, right? Correct?
Yes, yes, doctor.
Right. So basically, there now you have two options, right? One option is that this find method you have, you put minimal preconditions. This means you will accept any array, and that array, before you do the binary search, you will first sort it, and then once you have sorted it, then you will do the binary search. This is one option, right? Other option is you put a precondition here that, whoever is going to be sending me or calling my find method, he has to send me a sorted array. Now, in this case, it makes a lot of sense that you make your preconditions stronger and you take out certain computation out of this method to your client side. And because again, in this case, you actually, know your program. This is specifically for your own context of one system. Probably, who will be, will be checking it, where it will be called. Actually, that makes a lot of sense to put precondition in it, because, it will help you get results in a faster way. In other words, you don't want to slow down your methods and unacceptably slow, because you don't want to first sort them and then search it. We just put preconditions. So I believe you guys are now able to realize that, the rule is we want to minimize preconditions, but you have two extremes. One extreme is if you're writing classes like Java APIs. In that case, you like to minimize your preconditions, but at the same time, you cannot handle everything. So probably you will throw unchecked exceptions as part of your post conditions. While if you're developing applications specifically for one system, there you can easily put preconditions which are stronger preconditions, because you know your system. You basically, you can check your code, and you can actually, uh, really check where all the sites or calling sites are, because at the end of the day, using a precondition is more like an engineering judgment. It's like a design decision. And rule of thumb again is, yes, putting more preconditions will make your clients do some work, and it will limit it. But for a given application, this is probably a design decision you're willing to take to make your system, faster or more cohesive, and it's easy for you to actually even understand the overall context of the use or the scope of that method. While in a general cases like API and Java API cases, basically you can't really predict all of the scope of those methods, so hence you're better off having minimal preconditions, but throw unchecked exceptions for your post conditions. Everybody is comfortable with this concept as a rule?
Yes.
Great, straightforward, isn't it? So, alhamdulillah, this is basically, the whole idea of writing good specs. And, alhamdulillah, we come to the last, point of our material for 316. In a nutshell, specs acts like a crucial firewall between clients and programs. You want to separate them out. You want to do in such a way that, someone will give you an input. If you satisfy the input, the preconditions outputs are guaranteed. If you don't satisfy the input, outputs are unconstrained. And the reason you want to do these specs and the reason you want to write these specs is eventually because writing good specs will make our software, safe from bugs. How it makes safe from bugs is because, everybody is clearly defining what their method is doing, what are the preconditions, what are the post conditions. It's less ambiguous. You don't have to assume things about other methods. Hence, you will be calling methods in the right way. Hence, you are, minimizing the misunderstandings or the potential, lack of details about the specs. And of course, easy to understand, which is the biggest strength here, and which actually helps you reduce bugs. And of course, ready for change as well, because once you know your specs, you understand whether the preconditions are strong, post conditions are strong. If I want to change the specs of this method, I want to change the code of this method. By looking at the specs, you can understand that whoever is using these client is using this method, he's currenting these inputs. So if I make a change, as we discussed on Thursday, can I replace it or I cannot replace it, then this means you will have to go and look at other parts of the system. So it makes everything a bit more systematic. It makes your design more precise. And eventually, as a result of this, you're going to get all the benefits, which are associated with a good design. All right. So, alhamdulillah, as I said, earlier, um, we started off with the basics, and alhamdulillah, we come to this stage. Of course, we can always continue with some other more advanced topics of design, like OCL and object constrained languages, about all these specifications, especially, or some other advanced architectures and so on and so forth. But I believe for 316, this is something I always plan to cover. So alhamdulillah. So we'll be stopping here now, inshallah, and basically what we'll be doing now is uh, we are alhamdulillah done with the project as well. You guys submitted last night, so alhamdulillah. So basically we'll be using the next two lectures maybe and we have a huge two sections, large number of teams as well. So we'll be using project presentations inshallah in the next two lectures or two or three lectures, whichever are left. I'll open a Google Doc inshallah for you guys today, and you can sign up for an appropriate time slot for your presentation. Again, we are a larger teams of 6 here, so probably one student will be good enough to present. And I'll also give you very clear guidelines about what needs to be presented in the project presentation. I'm more interested in, because I have seen your submissions, I'll be grading your submissions, as well. So, but I'm more interested in seeing, what you learned, what was your experience, and, how you were able to somehow relate the things we learned in the semester. Of course, through the project and assignments were deliberately designed from another aspect. So with this, inshallah, the floor is open for any questions and discussions, and let me stop the recording and take the attendance as well.